In this example, I would like to show you how to solve the following inequality. The first step is if you do not have 0 on one side, get 0 on one side. In this case, I'm going to take this entire fraction and subtract it to the left. So I would have the original x minus 6 over x plus 4, and then minus x plus 6 over x minus 4, and then here it would be less than or equal to 0. Now, notice that this particular expression on the left-hand side is what we would call a rational expression, since it contains x's, and I'm going to say specifically x's in the denominator. You know that for rational expressions, there are certain places that the function might have a problem, and those are places where the denominator is 0. So make a note here that the two values that x cannot equal would be negative 4, that would make this that denominator 0, or positive 4, which would make that denominator 0. So we need to make a note of those two values. Okay, now what we are going to do is we're going to enter this entire left-hand side into y1. When you enter it into y1, you need to be careful to use parentheses around the tops and bottoms of each fraction. So you will enter it as y1 equals parentheses x minus 6, close parentheses, divide by, open parentheses, x plus 4, close parentheses, minus, open parentheses, x plus 6, close parentheses, and then divided by, open parentheses, x minus 4, close parentheses. So I'll go ahead and do that now. Okay, and once you have that entered, we'd like to set an appropriate window. I would say that for this particular problem, we don't really know what an appropriate window would be, and so let's go and just do a zoom standard to start, and we can see if that looks appropriate. Okay, that looks like it actually fits my graph fairly well. Some of you on your graph are actually going to have lines, vertical lines in between these particular pieces that I have. I'll explain and tell you what to do about those particular values. Okay, so here what I want to do is I want to sketch that graph. I used a 10 by 10 axis, so I'm going to start there. So 10 by 10 in all directions. Those vertical bars are the places that I would have what we call vertical asymptotes, and they are at the values that I made notes of that could not be plugged into the denominators. So here I would first actually want to go to negative 4, and I would want to draw a dotted line which indicates that this is not a part of my domain, and then do the same thing at positive 4. I know this, I can kind of eyeball it from my graph and it looks like that's where that is, but I know this because of those notes that I made at the front of the problem saying, hey, my x's can't be negative 4 or 4. So this is the first thing that you want to do. And then from the graph, it looks like my graph on the far left side stays above the x-axis and then gets drawn up towards this asymptote. In the middle, it looks like I'm going through 0. I can confirm that here in a little bit. I'm going up and to the right, and then I go through 0, it looks like, and then go down and to the left. We'll make sure here in a little bit that that actually is 0. And then on the far right side, it looks like I'm below, kind of going towards that asymptote, and then curving back up and going towards my axis, my x-axis. That particular piece will stay entirely below the x-axis, as this piece will stay entirely above the x-axis. Okay, let's go ahead and verify that this middle point is indeed 0. What I can do here is do second trace, go to 0. Okay, and it actually looks like it takes me to that point, but let's double check. It's asking for a left bound, go a little bit to the left, press enter, go a little bit to the right when it's asking for a right bound, press enter, and then press enter again. And in this case, we have an interesting situation of it gives me this strange looking value for x. Notice that there is an e and then a minus 13. What this means is it means take the decimal in this particular number and move it to the left 13 places. And so this would actually be 0.00000002475, whatever. And so this notation, when you see that, actually means x is equal to 0. Okay, so we have x is 0 and y is 0, and so this middle ordered pair that we have down here is indeed 0, 0. Okay, we don't need our calculator any longer, so I'm going to minimize that. And then all we need to do is look at our graph, and we're able to answer the question from here. Okay, scroll back up a little bit here, and notice what our inequality says. We know that the 0 represents the x-axis. Then notice that this is less than or equal to 0. What that means is on or below the x-axis. The on part comes from having the bar underneath. The below part comes from it being a less than inequality. So I want to know, where is my graph on or below the x-axis? So let's come back here, and I'm actually going to do this in red. So we look over here, we're above the axis, so it's not that. I look over here, and starting from this particular arrow and then going up, I'm below, and then when I get to right here, I'm actually on the axis. Looking here, that's not it because I'm above. And then finally coming over here and looking here. Oops, that's a little crooked. Looking here at my graph, I am below. And so on this particular example, my answers, we know they're always going to be an x interval, but the actual solution here would be starting very close here to -4, but not including it. Remember here, if we had those dotted lines that represents vertical asymptotes or numbers that are not in the domain, we cannot include those. So -4, we go to 0, we notice that point is actually on the axis, so we're going to use a bracket to include it. And then union, down here we get very close to 4, but because it's that vertical asymptote we cannot include it. And then it looks like we go out to infinity on this far side. So that would be our answer. Let's say in this particular situation, we would have had the exact same problem, but it had ended up being x minus 6 over x plus 4, and then minus x plus 6 over x minus 4 is strictly less than 0. We would have the same sort of work. The only difference would be our answer. Because we do not have the bar underneath that inequality, the answer would be -4 to 0, but don't include 0, and then union 4 to infinity. If we'd have had this other inequality here.